Introduction of lambdas and functional interfaces in Java 8 allows us to write the code in functional way. Today, we will see one such case where using functional interfaces could improve our code in variety of ways. Now, before going straight into the topic, first I'll describe the problem, what we are going to solve, and then present the solution itself in the later part of the video. So sit back and relax. Here I have a simple employee class with some instance variable like name, age, salary, department, and rating. I also have a one dummy employee service which returns the list of all employees. Now using these two classes, we try to describe the problem. Imagine that by invoking this API, you will get the list of all employees. Now you have a situation where you want to get the names of all employees whose ratings are 4. Now if you want to write this program, you would typically end up writing this piece of code. Get employee names with ratings. It takes a list of employees as a first argument, and the second argument is the rating. Now this is a very straightforward code. You iterate through each and every employee in the list, and you check for each employee whether the rating is equal to the given rating or not. If it is equal to the given rating, we add to the result and we return to the caller. Now if you execute this program, you will find the three names Jack, Edward and Ella are returned because they have rating exactly 4. Now before coming into the conclusion that this code works perfectly fine, hold on. It's not pretty obvious that there is something wrong with this code. Let's find out why. Now let's say you have another requirement to get the names of all employees with a given department. Now what you do is you copy the whole piece of code and write a whole new method again. Let's see what we can do. Copy this whole code and paste it right here, and we call it get employee names by department. So we take a string argument here, say that it is department, and we change the filter here, get department dot equals the given department. So if you see this, both methods, both are looks like pretty identical. We iterate to the whole list and we check for the condition, and if it satisfies, we add it to the result and return. And let's try to execute this method. Let's say we want to use this method instead of this, and we want to get employees with development department. And we try to execute this program. Now you got three names, Chris, Jack and Edward. These belong to the department development. Now even now it may not be too obvious to recognize the problem. Now if you keep adding the requirements to get the names of employees with some criteria, let's say for example get employees with certain age, or get employees with greater than certain salary, or get employees within the department with certain ratings, you would end up writing the whole lot of methods with identically looking code. Now we definitely don't want that. Duplicate codes are like hidden bugs waiting to be discovered sooner or later. Now what we can do to improve this situation? Let's see how we can use the functional interfaces to improve the above situation. Now the predicate is a very simple interface with only one method called test. If you look at the signature of a test method, it takes a single argument and returns a boolean value. Now we'll try to use this predicate in our example and see how we can improve the code. if you rewrite this whole implementation using the predicate functional interfaces, you would typically end up writing this method. Now, if you look at the implementation of the method, nothing much has changed from the code perspective. But the big change is in the second argument. Now we take the predicate interface as a second argument to the method. Now inside the code, we use the test method of the predicate, and based on the result, we add the employee's name to the result. Now you may ask, who implemented this predicate interface? The answer is client. If you see the calling statement using the lambda expression, we have implemented the predicate's test method. Remember the test method signature, it takes one parameter and returns the boolean. Now this lambda expression takes one parameter employee and it returns the boolean, and in this case employee ratings if it is equal to 4 or not. Now the advantage of this code is, no matter what the filter is to get the employee names, you could always end up using the same method with different arguments. Now let's say you want to get the employee names with age greater than 30. So you could just simply change this lambda expression. That's it. Now there are two employees whose age is greater than 30. Now as simple as this, you can change the filter, like you want to get the employees whose department is development. Get department dot equals development. Let's see if we can execute this program. Yeah, you got the output. Now this is great for two main reasons. From the client perspective, he's not restricted anymore from the API to use a fixed filter. And now from the API perspective, he made the filter as a configurable thing. Client can send whatever he wants to filter. The API doesn't have to bother. Now this is also called loose coupling. Lastly, you could achieve the similar thing in Java 7 as well, but it's a long procedure without lambdas. And also congratulations, you have just learned the strategy design pattern. So that's it guys, see you in the next video.